In the online collaborative exercise, participating students next look at what happens if the number of individual insects reaching the new island is somewhat larger. Here we see one of these larger founder populations. This time, every one of the 10 different genes in the parent population is represented in the founder population. The allelic diversity is 10, as in the parent population. All 10 of the different coloured genes has made its way onto the island. With these larger founder populations, again the students each claim one of the islands and put their initials against it. They count how many of each coloured gene is in their founder population on their island and enter the data in this table. Students are invited to record their observations by answering some questions as before. Their answers are entered on a wiki, which builds up into a more useful document as more students add their comments. One of the questions is there a relationship between the likelihood of an allele being represented in the founder population and the size of that founder population? The answer, of course, is yes. Small populations are more subject to evolutionary change by genetic drift than larger ones. This is what is known as the founder effect. The next question asks, what are the implications for the genetic diversity of populations which originate from a very small number of founder individuals? The answer is that as these populations will have such low genetic diversity, they are left potentially vulnerable. A population with low genetic diversity lacks the potential to adapt to change in a changing environment. The conclusions become clearer as more students enter their suggestions on the wiki. Students then go on to engage in a quantitative comparison between the small and large founder populations. They calculate the genetic differentiation between their small founder population and the parent population, and then between their large founder population and the parent population. When a number of students have entered their estimates of genetic differentiation, or FST, it becomes clear that the value of FST between the parent population and the small founder population is consistently larger than the value of FST between the parent population and the larger founder population. Guidance is given on the wiki to help any students who are finding the calculations difficult. We then go on to look at what the genetic differentiation can tell us and what the limitations are of this particular parameter. Students' comments are entered on the wiki, and the students' conclusions from this activity in the form of their answers to the questions are added to the wiki as time goes on. This activity was first trialled as a tutorial exercise with one tutor group of Open University students studying S366 evolution. It was piloted in 2009 as a wiki-based activity to students in that tutor group who were unable to attend tutorials. This year it's been presented as an online activity for a much wider group of students. Students can engage with this as a voluntary exercise at any time at their convenience. It was made available in the middle of May 2010 to all Open University students studying S366, which is evolution. By the beginning of June 2010, 22 students had participated. As more participate, the data becomes more robust, and the differences between the different islands become more clear. It will remain available for current students until the course finishes in October.